Welcome to EDU World Space.
This is chapter 21, problem number 38. In the first part of the problem, we're asked the net electric field at the origin due to these two charges. Both of them are positive. So let's start with the first charge. I'm going to call this Q1, and I'm going to call the second one Q2. And the fields due to these charges, due to Q1, for instance, we know that it's a positive charge. So at the origin, the electric field that it generates is going to be away from this positive charge. So let's call this E1. Now, the same logic is valid for the second charge, right? It's positive Q, so it's the field that is generated by this charge is radially outward, right? So let's call this E2. This was supposed to be a straight line. Okay, all right. Now, one thing that is worth noticing is that there is a triangle here, as you see, and the sides of that triangle is L, which makes the angle 60 degrees here, right? So if this angle is 60 degrees, so is this angle. So the angle between E1 and E2 is 60 degrees. And now all we need to do is actually find the E1 vector, find the E2 vector, and add them in order to find the net electric field at the origin, right? Before we do that, E1, well, let's do E1, right? E1 vector equals to the magnitude, which is KQ over the distance between where the first charge is located to the point that we're interested in, which happens to be the origin in this case, which is L squared. This is the magnitude of the field. Now let's add the direction to it. Since it's pointing down, it's negative J hat direction, right? It's in the negative Y direction. Perfect. So if we want to do pretty much the same thing for the second vector, we're going to notice immediately that E2 is applied with an angle with respect to X and Y axes. So we need to figure out the components in the X and Y axes, right? So let's say if we're looking for the X component of E2, so E2X, then is going to be equal to, let's write it down here, E2X is actually E2 times the sine of 60 degrees, right? And if we do the same for the Y component, we're going to see that it's pointing down just like E1, but a little shorter than that. So it's E2Y, then E2Y is going to be E2 times cosine 60, right? And what is E2 in this case? So when we're writing the E2 vector, you know that first we write E2 sine 60, the X component, times this X component is in negative X direction, so we're putting negative I hat there, plus E2 cosine 60, and Y component is also pointing down, which means the unit vector that we need to use is negative J hat. We still didn't calculate what E2 is. So if you look at E2, the magnitude of E2 is actually KQ over, again, L squared, correct? This is E2. And sine 60, let's remember that sine 60 is actually square root of 3 over 2, and cosine 60 is 1 over 2. So it's for sine 60, we can write square root of 3 over 2. This is negative I hat plus KQ over L squared, right? Cosine 61 over 2, negative J hat. All right, now we have E1 and E2 vectors. All we need to do is now to add them to each other, right? Let's do it on a new page. So then the total E equals to E1 plus E2, which is, let's write E1, KQ over L squared and negative J hat plus KQ over L squared square root of 3 over 2 negative I hat plus KQ over L squared 1/2 negative J hat. Right? Now let's group the I hats and J hats. The only term as far as I hat is concerned is this negative I hat plus for j hat, what we have is kq over L squared. Let's write the first term plus kq L squared times 2. So I'm going to write 2L squared here negative j hat, right? So this first term with the negative sign is then Ex, the x component of the net field. The second term, including the negative, then is the y component of the net field at the origin. Now, how are we going to calculate the magnitude? As you know, the magnitude is E sub x squared plus E sub y squared, right? So then let's remember A sub x is kq square root of 3 over 2L squared. The negative of it, but we're going to take the square, so that's not a big deal if you forget at this point. Plus, we have this term, so it's 3kq negative 3kq over 2L squared, but the square of this, right? So from here, then, let's take the square of the first term. We have k squared q squared 3 over 4L squared plus 9k squared q squared over 4L squared. So 9k squared k squared plus 3, so it's going to be 12, right? Let's do it on the new page. 12 k squared q squared. In denominator, we have 4L to the power of 4, but we have the square root of this. So that is going to be equal to square root of 12 kq over 2L squared. So square root of 12 is 2 square root of 3, as you know. So kq over 2L squared. 2's are going to cancel here. So what we have as the net force, the magnitude, net field at the origin to be square root of 3 kq over L squared. Now let's look at the direction of this electric field. How? By looking at the tangent, right? Then the y component of the net field divided by the x component of the field is going to give us the tangent. If you remember, the y component of the field was 3kq over 2L squared. The x is, I'm taking the inverse of it, 2L squared over kq squared of 3. Now, 2L squareds are going to go away. kq, square root of 3, I have square root of 3 left, right? So, inverse tangent of square root of 3 then is going to give me my angle, which happens to be 240 degrees. All right, now in part B, we're basically given the same diagram. However, this time, let's remember, this is Q1. We call it positive Q. This time, the second charge here, Q2, it has flipped signs, right? So still, the rest is pretty much the same. We have the triangle, all lengths are equal to each other. We're still looking for the electric field at the origin. Again, the electric field, the first electric E1 doesn't really change at all, right? It's the same. This is the direction of E1. Even the magnitude of it is the same. So E1 is still kq over L squared negative j hat, right? However, E2 now is going to flip direction. It used to be in the negative x and both x, y directions, but now it's going to be towards this negative charge, due to negative charge generating electric field towards themselves. So this is going to be our E2. Again, we're going to do pretty much the same thing. This angle is 60 degrees. So if we're looking for the y component of this E2, E2y, then let's write it down. E2y then equals to E2 cosine 60, right? And E2x then is going to be something like this. E2x is going to be equal to E2 sine 60, right? And if I want to write the E2 vector, then E2 sine 60, this time it's positive I hat, right? Plus E2 cosine 60, positive j hat, because now the y component is up, right? So E2, as you remember, was kq over L squared. Sine 60 is square root of 3 over 2. I hat kq over L squared. Cosine 60 is, cosine 60 is going to be 1/2, pardon me, j hat, right? So this is our E2 vector. The first one is E1. Again, the net electric field is the summation of these two individual electric fields at the origin, right? So E equals E1 plus E2. All we need to do is put E1, and remember kq over L squared negative j hat, plus, now I'm writing E2 and kq L squared square root of, this is an L, square root of 3 over 2 I hat plus kq over L squared 1/2 j hat. Again, I'm going to group the I hats and the components of I hat and j hat. In the I hat, I only have kq over L squared square root of 3 over 2 I hat. For y, I have kq over 2L squared minus kq over L squared j hat, right? So ex, the x component of the total field, this would be the y component of the total field. As you know, the magnitude of this field is going to be equal to the square of the x component plus the square of the y component. E sub x is kq over L squared square root of 3 over 2 squared, plus ey is negative kq over 2L squared squared. Now from here we have k squared q squared 3 over 4L to the power of 4, and here k squared q squared over 4 times L to the power of 4. So then when we add them to each other, we have 3 k squared q squared and 1. So it's 4 k squared q squared over 4L times L to the power of 4. As you know, 4's are going to cancel here. So we have k q over L squared as the magnitude when we flip the sign. And then in order to calculate the angle, we're going to do tangent theta again. Ey over Ex is our formula. Ey is negative kq over 2L squared, and Ex, inverted version, 2L squared over square root of 3kq. And now let's see what's canceling out. Kq's are going to cancel out. 2L squareds are going to cancel out. What we have is negative of 1 over square root of 3. And that when we take the inverse of the tangent of negative 1 over square root of 3, we find our angle. And in this case, our angle is 330 degrees.